In this lesson, we will learn about selection sort. Let's take the same cards we used for bubble sort and try sorting them using the selection sort method. Like in bubble sort, here also we will make multiple passes through the cards to sort them. In the first pass, we will look at all the cards and find the smallest card. 2 is the smallest of these 4 cards. We will swap this 2 with the first card. Now 2 is in its correct position. So after the first pass, we have sorted one card. In the next pass, we will find the smallest of these 3 cards. It is 3. We will swap it with the second card. At the end of the second pass, the first 2 cards are in their correct position. In the third pass, we will find the smallest of these 2 cards, which is 5, and swap it with this third card 9. At the end of this pass, we have sorted all the 4 cards. To summarize this process, we can say that selection sort divides the array into 2 parts, sorted subarray and unsorted subarray. In each pass, it finds the minimum element of the unsorted subarray and swaps it with the leftmost unsorted element, moving the sorted subarray one element to the right. Now let's switch to BlueJ and see the selection sort Java program. Like bubble sort program, here too I have added this display array method and a few additional print statements to get a detailed output explaining each step of selection sort process. After going over the program, I will remove these print statements and show you the program to give just the sorted array as the output. Let's execute the program and get the detailed output. We start the main method by declaring and initializing the array ARR and storing its size in int variable n. Notice that it is the same array that we used for bubble sort. After this, the core selection sort logic starts. This outer loop controls the number of passes we make through the array. To sort an array of size n, we need to make n-1 passes through it. Size of ARR is 4, so it will take at the most 3 passes to sort it completely. So the outer loop runs from 0, which is the starting index of the array, and keeps iterating as long as I is less than n-1. We print the pass number and then we declare an int variable idx and initialize it with I. This variable idx will hold the index of the smallest element in the unsorted part of the array. Initializing it with I means that we start the pass by assuming that the first element of the unsorted part of the array is the smallest element. Then, as we will look over other elements in the inner loop, we will update the value of idx if we find an element which is smaller than the element at idx. In the inner loop, we go over each element of the unsorted part of the array and check if it is smaller than the smallest element that we have found so far. Here, j is initialized to I+1. The reason for this is, in each pass, the length of the sorted part increases by 1. Recall from the cards example that as we were making our passes through the cards, they were getting sorted from left to right. So, we compare the cards from I+1 till the end of the array using the condition j less than n. If this if check is true, it means that ARR of j is the smallest element we have seen so far, and we update idx accordingly. At the end of the inner loop, we have the index of the smallest element in idx. We swap the element at index idx with the element at index I. Then we print the array just before the outer loop ends. Once these nested loops complete executing, our array is sorted. So we display the final sorted array as the output of the program. And with this, our selection sort program completes. Don't worry if you're still feeling a bit uncomfortable with selection sort. Next, we will do a dry run of the program which will make its working clear. This is the array that our program will sort. N gets the value of 4 as there are 4 elements in ARR. The outer for loop starts by initializing I to 0. At this point, the entire array is unsorted, so the size of our sorted subarray is 0. Condition of outer loop is true, so we start our first pass through the array. IDX gets the value of 0. Remember, IDX will hold the index of the smallest element of the unsorted subarray. After that, the inner loop starts and j is initialized to 1. ARR of j is 5, ARR of IDX is 9. The two are compared, and as 5 is less than 9, we update the index of minimum element to 1. Program control goes back to the beginning of inner for loop to compare next elements. J becomes 2, condition of inner for is true, ARR of j is now 2 and ARR of IDX is 5. The two are compared, and as 2 is less than 5, we again update the index of the minimum element to 2. Next iteration of inner for loop starts. J becomes 3, condition is true, so ARR of 3, which is 3, is compared to ARR of 2, which is 2. IDX is not updated this time as 3 is greater than 2, so the condition is false. We don't want to update IDX as it is already pointing to the smallest element. Program control goes back to the beginning of inner for loop. J is incremented to 4. This time the condition is false, so program control jumps to this statement after the inner for. These three statements swap the values of 9 and 2. Next, we print the updated array after this swap. And with this, our first pass through the array completes, and we have sorted the first element of the array. Length of sorted subarray is now 1. Program control goes back to the beginning of the outer for. I becomes 1, condition is true. We start our second pass through the array. This time IDX is set to 1, the index of first element of our unsorted subarray. Inner loop starts, j becomes 2. Condition is true, ARR of j, which is 9, is compared to ARR of IDX, which is 5. The if condition is false, so IDX is not updated. In the next iteration of inner for, j becomes 3. Condition is true, ARR of j is 3, ARR of IDX is 5 like before. The if condition becomes true and IDX is updated to 3. Program control goes back to the beginning of inner for and increments j to 4. Loop condition becomes false and program control comes to this statement after the inner for. 5 and 3 are swapped. Array after the swapping looks like this. Its first two elements are sorted. Length of the sorted subarray is now 2. Program control again goes back to the beginning of the outer for. I becomes 2, loop condition is true, we start our third pass through the array. IDX is set to 2, inner for loop begins and j is initialized to 3. Condition is true, ARR of j is 5 and ARR of IDX is 9. Both are compared and the condition is found true. IDX is updated to 3. Program control goes back to the beginning of inner for. J is incremented to 4. Now the condition of inner for loop becomes false. So it is not executed and program control comes here. 9 and 5 are swapped. These two statements again print the updated array to the console. Program control goes back to the beginning of outer for loop and increments I to 3. This time the condition of outer for loop becomes false. It stops executing. Program control comes to this statement after the outer for loop. The sorted array is printed to the console and our program completes. Now that we have the complete understanding of selection sort program, let's remove all the extra print statements and the display array method we added for this detailed output, and just look at the selection sort program only. These are the nested loops of selection sort, and after that, we print the sorted array. Let me execute it and show you the sorted array as the output. This table summarizes the selection sort steps of sorting the array ARR which we discussed just now. You can use this as a reference to revise selection sort. Let's conclude our discussion of sorting by comparing bubble sort and selection sort. I will let this table fly away. Bubble sort uses item exchange method. It compares adjacent items and swaps them if they are in wrong order. Selection sort uses item selection method. It selects the smallest item from the unsorted part of the array and swaps it with the leftmost unsorted item. Because of this, even though both bubble sort and selection sort make the same number of passes through the array, selection sort makes fewer swaps than bubble sort. In the example program that we saw earlier, bubble sort made 5 swaps whereas selection sort made only 3 swaps to sort the same array. This makes selection sort relatively faster than bubble sort. Another difference between bubble sort and selection sort is that in bubble sort, the array is sorted from the last element to the first element, whereas in selection sort, the array is sorted from the first element to the last element. And with that, we have completed our discussion of the sorting algorithms. After this, we will look at double-dimensional arrays.